Hello, everyone. Today we're going to start out with a review of transformations of square root functions. Now, this isn't what the complete lesson is about today, but this will be good to review. So, if I look at the equation that we're given and I look at the parent function on the graph, I'm looking at how these extra numbers here are changing the shape of this graph. So if I look at this graph, originally it is going up, right? It is facing up. Now, when I look at the first thing in this new equation, I look at that -2. What does that negative tell me? It tells me that my graph is going to be facing down instead. Okay, it's going to be reflected across the x-axis. Why? Because the -2 is negative. Then I look at the fact that it's a 2. The fact that it's a 2 means that it is going to stretch because the absolute value of -2 is equal to 2, which is bigger than 1. Okay, so remember that the negative has to do with it facing up or down, and then the fact of the absolute value being bigger than 1 tells me that it is a stretch. Then I look inside of the square root and I see that we have x plus 5, and that tells me that our new graph is going to move to the left 5, because of the x plus 5. And remember that inside of the parentheses, it is going to move opposite of what we think. And then finally, I don't see a k value being added out here, so my graph is not going to move up or down because I don't have a number adding or subtracting at the end of our equation. So if I were to look at my new graph, it would look something like this. Okay, this is my new function. So it reflects across the x-axis. It flips upside down. It is a vertical stretch, so it is a bit taller than our original graph, and it is shifted to the left by 5. If I look at the attributes of this new graph, if I look at the domain, okay, I'm looking at where it starts, the x value that it starts at, and then how far to the right it's going. So since it starts at -5 and goes to the right forever, this is one way that I could write my domain, from -5 to infinity. The other way that I could write it, since domain is talking about our x values, is that x is greater than or equal to -5 since it is going to the right. For my range is my y values, or how far up or down it's going. So I look at where it's starting. I see that it's going to go down forever. Okay, if I typed this equation into Desmos, I would see that it does go down forever. So it starts from -infinity, because remember, we write it in order from bottom to top, from -infinity up to 0. The y value there is 0. The other way I could write this, since it's going down, and range is talking about y values, is that y is less than or equal to 0. Then I look at my x-intercept. My x-intercept is -5, 0. Then I look for my y-intercept. And if you look in Desmos, it'll give you the most accurate one. But my y-intercept is 0, -4.472. My vertex happens to be in the same spot as my x-intercept. It is also called the starting point for a square root graph. And here it is -5, 0. Then finally, we look at if our graph has a highest point or a lowest point, and our graph does have a highest point. This is where it stops. It stops up at the top and goes down forever. So it would be a maximum. And remember that it is going to be the highest y value. So my maximum is 0. And remember that it is also the y value of the vertex. Okay, but today we're going to talk about solving square root equations. So solving an equation involving square roots and identifying an extraneous solution. We're going to talk about what an extraneous solution is also. So when I'm solving an equation, remember, I'm always wanting to get x alone. Here, I have to start with the thing that's furthest away from x. There's a square root, there's a plus 7. The thing that's furthest away from the x is this plus 7, so I'm going to start out with subtracting 7 from both sides. Then I end up with square root of x equals 9, because 16 minus 7 is 9, and I want to get rid of this square root. So I have to do the opposite of a square root, which is squaring. So I'm going to square both sides. The squaring of a square root will cancel it out. So I'll have x equals 9 squared. And since 9 squared is 81, because that's 9 times 9, my answer is that x equals 81. If I continue, looking at the next example, it is the same idea. All right, I add 5 to both sides, and that gives me square root of x equals 3, because negative 2 plus 5 is 3. Then I want to get rid of the square root, so I square both sides, and that gets rid of the square root, so I just have a plain x. X equals 3 squared, and since 3 squared is 3 times 3, x equals 9. Now I see something a little more complicated. There's a bit more involved here, but it is the same idea. Okay, I want to start with the thing that is furthest away from x. So the 2 is right next to it, then there's a minus 3, a square root outside of it, and then there is a 3 being added. This is the thing that is furthest away, so that is what I'm going to get rid of first. I will subtract 3 from both sides. Square root of 2x minus 3 equals 5. I want to get rid of the square root first, so I will square both sides. That gets rid of the square root. So 2x minus 3 equals 5 squared. And 5 squared is 5 times 5, so 2x minus 3 equals 25. Then add 3. So 2x equals 28. And then I divide both sides by 2 to get rid of that 2. And that leaves me with my answer that x equals 14. Same idea in the next problem. Okay, start with the number that's furthest away, minus 5. So I'm going to add 5 to both sides. Okay, here that cancels it away. Here, 0 plus 5 is 5. So now I have square root of 4x plus 1 equals 5. I square both sides to get rid of the square root. We'll see that here it does get rid of the square root, leaving me with just 4x plus 1 equals 5 squared. 5 squared is 5 times 5, which is 25. So I have 4x plus 1 equals 25. Then I subtract 1 from both sides, leaving me with 4x equals 24. I divide both sides by 4, and that leaves me with x equals 6. All right. Moving on. Sometimes our examples look a little different. Sometimes I will have an extraneous solution. So when we're solving an equation, sometimes we might find 2 answers, but one of them is actually not valid. It actually doesn't work out when I try to plug it back into the original equation. So let's say I have an example like this. Right away, what you should notice is that here I have the x inside the square root, but then I have another x outside of it. This is normally when I have a problem, when I have a variable outside of the square root, like over here. Check your solutions. And so when we say check your solutions, what does that mean? Let's say the answers to this problem are x equals 4 and x equals 9. But we have to check. If I replace the x in the original equation with 4, I see that 4 minus 6 is negative 2, and square root of 4 is 2. Negative 2 does not equal positive 2. Those are 2 different numbers. It's not true. if I plug 9 back in, okay, replacing this x with 9, replacing this x with 9, 9 minus 6 is 3, and square root of 9 is 3. 3 does equal 3. That's true. So between x equals 4 and x equals 9, my only valid answer is x equals 9. X equals 4 is extraneous because it doesn't actually work out. So let's see a full example, and bear with me because it is a long process. So here I am seeing an x on the other side of the equal sign, not underneath the square root. I do have to get this square root alone because I'm trying to get rid of the square root. So I am going to start by adding 5 on both sides. Okay, so that leaves me with square root of x plus 7 equals x plus 5. Then I want to get rid of the square root, so I square both sides. That gets rid of the square root, so it just leaves me with x plus 7. And here I've got x plus 5 squared. Now remember that when I square something, it is just multiplying that same thing by itself. So x plus 5 squared is x plus 5 times x plus 5. How do I multiply this? Remember that we use the box. Okay, I'm multiplying this by this. I do that using the box. X times x is x squared. X times 5 is 5x. 5 times x, 5x. And 5 times 5 is 25. All right, so really what this ends up becoming is x squared plus 10x, because these are like terms, so they combine, 10x plus 25. So this side of the equation stays the same. Nothing has happened, but this side ends up changing. X squared plus 10x plus 25. So this is coming from here. Now, when I'm solving an equation like this, if you remember from the previous class, I want one side of my equal sign to be 0. So I have to get rid of this x and this plus 7. I have to move them to the other side. So I'm going to subtract x and subtract 7. And this leaves me with 0 on this side, because look, I took away everything, equals x squared minus, when I do 10x minus x, that gives me 9x, and when I do 25 minus 7, that gives me 18. So now this is what I'm working with. This is what I have to solve. If you remember from last class, I have to factor to solve this equation. And remember, I factor using the box. First, I know that in this first space, I can put x squared, and in this last space, I can put 18. And remember, that's always the case. The first thing goes in the first box, the last thing goes in the last box. But the question is, what goes in the middle? So remember, I have to know my A, my B, and my C. And I'm looking for factors of A times C, so 18, factors of 18, numbers that multiply to 18 that end up adding to 9. So I make my list. 1 times 18 is 18. 2 times 9 is 18. And 3 times 6 is 18. So if I go through and I think, what's 1 plus 18? That is 19. Not this one. 2 plus 9 is 11, so not this one. 3 plus 6 is 9. So I want to be using these numbers. So in the middle, diagonal, that I haven't filled out yet, I am going to have a 3x from here and a 6x from here. And that works out because if I add these two together, it is going to give me back this 9x that I should have. And from there, I can factor. So since x squared and 6x both have an x, I can take that out. And if I want to get x squared, I should have another x up here. To get 3x, I'd have to multiply another 3 with x to get 3x, so the 3 should be out here. And up here, if I want to get 6x, I would have to multiply with x a 6. So this is what I end up with. And so when I write this as a factored equation, instead of having 0 equals x squared plus 9x plus 18, I'm going to have 0 equals x plus 3 times x plus 6. And remember, these are coming from here, from the outside of the box. From there, I can set up my equations. Remember that 0 would equal x plus 3, my first factor. And then I would get that x equals negative 3. My other equation, 0 equals x plus 6, I would get that x equals negative 6. Now I have to check my answers. Remember, I have to plug them back into this original equation. So you can always use Desmos for this, and I'll show you. But if I plug back negative 3 for where x was in this equation, and I check negative 3 plus 7, okay, equals negative 3 plus 5. I actually kind of plugged it into this, but either way, it's the same. I would get that 2 on this side, and I would get a 2 on this side. 2 does equal 2. Hooray, that's true. When I plug negative 6 back in, though, negative 6 plus 7 is 1. The square root of 1 is 1. But then I get that negative 6 plus 5 is negative 1. 1 does not equal negative 1. So my only true answer is x equals negative 3. There's only one. Seeing another example, the same idea, okay? First, need to get this square root alone, trying to get rid of the square root. So first, I need to subtract 3 on both sides. So I've got square root of 5x minus 1 equals x minus 3. Cool. I get rid of the square root by squaring both sides. That gets rid of the square root. And remember, now I need to expand this side, figure out what this actually is. X minus 3 squared is x minus 3 times x minus 3. So I want to multiply that out. I use the box to do so. X minus 3 times x minus 3, gotta draw a box. X times x gives me x squared. X times negative 3 gives me negative 3x. Negative 3 times x gives me negative 3x. And negative 3 times 3 gives me positive 9. Okay, so when I write this all out, I get x squared. I add these together, gives me minus 6x, and then plus 9. And of course, nothing changed with that. I want to solve this. It's got an x squared in it. I need to get everything to one side. This needs to be equal to 0. So I can factor it. So I'm going to subtract the 5x from both sides and add 1 to both sides. So the equation I'm going to be working with in factoring is 0 equals x squared minus 11x plus 10. So remember to factor, we are using the box. In the first space is going to go x squared. In my last space is going to go my last term, which is that 10. And I need to figure out what's going in these middle two boxes. So in order to do that, I need my a, my b, and my c. I'm looking at factors of a times c. So a times c is 1 times 10, which is just 10. And I'm looking at factors of positive 10 that add up to negative 11. Now, since it's a positive 10 and it adds up to negative 11, my pairs of factors are both going to have to be negative numbers. Since a negative times a negative is a positive, that works out. So my options are negative 1 times negative 10 or negative 2 times negative 5. So when I use Desmos to try and add these together, see which ones equal negative 11, it will be negative 1 and negative 10. So in the box, I'm going to have a negative 1x here and a negative 10x over here. Now as I'm trying to figure out what goes on the outside, I look, okay, what do x squared and negative 10x have in common? In x. What am I going to have up here? An x, because x times x is what's going to give me x squared. Out here, I would get negative 1x by multiplying x with a negative 1. And then in order to get this positive 10, I have to multiply negative 1 with negative 10. So a lot of ways you can think about it as long as you think of the puzzle piece. What do I have to have out here to give me what's in here? So my factored equation is going to be x minus 1 times x minus 10. So I'm going to have my first equation that 0 equals x plus 1. And so for this to be true, x would have to equal positive 1. And for this second equation, I've got 0 equals x minus 10. And x would have to be positive 10 there. So again, taking these values, I get two solutions, but not both of them are going to be valid. I take this x value, plug it back into my original. All right, replace that x with a 1 on both sides. And I get, and on the other side too. So this is what it looks like when I plug it back in for x. For the first one, I get that 5 equals 1. 5 does not equal 1. Those are two different numbers. But for my second one, I get that 10 equals 10. So my actual answer is going to just be that x equals 10, x equals 1 is an extraneous solution. Finally, we're just going to look at a word problem. How would we do something like this? So the equation here represents the company's profit, P, in millions of dollars, and X is the year. So using this model, they're asking when, that's time, what year, will the company's profit reach 5.94 million? So since P is dollars, millions of dollars, and here they give us $5.94 million, that means that I'm going to be replacing P in my original equation with 5.94. And from here, I am just solving for x. So I have a minus 1980, I have a square root, and I have a 1.4. The thing that is furthest away is this 1.4, so I have to start by dividing by 1.4 on both sides. 5.94 divided by 1.4, you can use your calculator for this. It is 4.24 about, I rounded it. Next, I have to get rid of this square root. So we square both sides, that gets rid of my square root. And 4.24 squared is 17.98. Again, I'm rounding. And then to get x finally completely alone, I need to get rid of this minus 1980. So I add 1980 to both sides, and that leaves me with my answer, which I rounded again to my nearest year, but it'll be about the year 1998. Okay, so if you guys have any questions, please let me know. I did change the wording in this problem a little bit because it didn't make sense before with the answer that we get. So please keep that in mind. It does look a little different, but the idea is the same. Okay, bye.